And the next stage, the next phase would be to put springs on the pieces of steel.
Oh, what a coincidence. He's such a schmuck, isn't he? You can't be honest and say, I've just seen Steve saying he's put springs on, replicated my experiments and put springs on, and got totally fucking different results, exactly like Walter Lewin's instead of his, Gary's. But you can't say that, can you? You can't give anybody else credit. He has to try and make it look like it was his idea. Good one, Gary. And you can put rubber on as well, Gary. And you can put fur rubber. And you can stick an egg on the end of it. And you're going to pray to your fairy godmother or something as well. You cunt. Oh, what a coincidence. Oh, what a coincidence. As soon as I tell Lance Bradshaw, as soon as I tell someone about me having put springs on Gary's experiment, and explaining that it needs springs because his experiment is fundamentally flawed. His experiment is fundamentally flawed, so it needs springs. Oh, all of a sudden, Gary realizes he needs springs too.
And the next stage, the next phase would be to put springs on.
The question is, Gary, why didn't that cross your mind in the first place? Because that's the most obvious thing you need in this experiment. That looked more like a Newton's Cradle type thing, didn't it? Because it was elastic. Okay, so notice in Gary's experiment that the light object on the right doesn't bounce off the heavy object on the left. It carries on following it after it's had the collision. It's supposed to deflect off it because it's supposed to be an elastic collision, a proper elastic collision. He's not making any attempt to make it the same as Walter Lewin's experiment. He's moving the goalposts again. See if we can find another example. Here's the collision. There we go. Right, so just watch it. It's not going to bounce off, is it? It should do, like in Newton's Cradle. Look, it's carrying. It's following. It's following the heavy object. It's like Benny Hill after a woman. Yeah. Do you know, I think he likes to freeze it so you don't get to see the whole thing. I'm trying to look for... Anyway, you get the picture. It's not bouncing up anyway, that's the point. That looked more like a Newton's Cradle type thing, didn't it? Because it was elastic. Okay, right now I'm going to show you me measuring the velocities of the incoming one mass, the outgoing two mass, and the reflecting one mass, and you'll find that they're the exact same ratios as Walter Lewin found in his air track experiment. You've got 3/3 for the one mass coming in, 2/3 for the two mass going out, and 1/3 velocity, the one mass reflecting back off it. You don't find that if you do it with Gary's experiment, which isn't a proper elastic collision experiment. Whether he knew that or not, I don't know, but I wouldn't put it past him to figure he's going to try and nobble the experiment, cheat the experiment to try and make it so it looks like it's not doing Walter Lewin's thing. Well, I've usurped him. I've just done the experiment with springs, and now he's claiming. Oh yeah, that was my next plan. Yeah, right, Gary. He's such a cunt. Here we go. So I'm going to start forward in one frame at a time. Okay, 1, 2, 3. You can see the two mass creeping forward, so it must have been swinging a bit. 4, 5, 6, 7, 8, 9, 10. Oh, it's 11, 12. Ah, so there's our release. So let's count from this point then. Okay, let's count from this point. 7 1/4, the front of the spring. Okay, how does that sound? 7 1/4 from the front of the spring. 1, 2, 3, 4. Okay, so over four frames again. That might be a convenient number again. So over 4 frames, it's gone exactly 2 inches from 7 1/4 to 5 1/4. Might be just the slightest bit over, but I think if I click it again, it'll actually have struck the other spring by then. So let's have a look. So that's 4 frames, and it's covered 2 inches, the one mass. So there's the collision. Let's go back one now. Oh yes, that's the exact point of collision. Hang on. Oh, so in that case, yeah, so the two mass object hasn't actually moved yet, has it? It's just they've met, the springs have met. So instead of saying 2 inches, we could say, instead of 2 inches, just over 2.5 inches, isn't it? 2.2.5 inches, I'd say. So instead of 2.5 inches, let's call that 2 2 okay? 2 and 5/8 inches then, over 5 frames, okay? So that's the point of collision. Now, before we do it, we would expect, if this was obeying, Walter Lewin's thing, we would expect it to, yeah, we want 2/3 of, if I'm able to measure 5 frames of the next one, then we would expect that to have done 2/3 of that. Now, what's 2/3 of 2 and 5/8? A bit under 2 inches, isn't it? It's going to be like 1 3/4 inches or something, isn't it? If I get a calculator up. What's 5/8? 1 divided by 8 times 5 equals 0.625. Okay, so we've got 2.625. Divide that by 3 times 2 equals, so 1.75. Yeah, so we're looking for 1.75 inches from the 2 mass. I wonder if we actually have that. Here we go. 1, 2, 3, 4, 5. I need to interject here because I've just realised, watching that again, that sequence of counting the 5 clicks, the 5 frames forward of the 2 mass, that the last frame, it hardly moved at all. So it was at the back end of its ability to move. So that isn't a true description of its actual velocity. So the velocity will be a bit bigger than I predicted in the following calculations. I'll play it back again in case you want to check that. Here we go. 1, 2, 3, 4, 5. So it's ended bob on the 3-inch mark. So it's 1 inch and 5/8, isn't it? It's moved 1 inch and 5/8 instead of, so instead of 1.75, it's actually done 1.625, and so it's a tiny bit slower than it should have been. No, I've dropped a clanger there. It actually is the right speed. I've underestimated the speed there because that last click, it hardly moved at all. It didn't really count. But then again, it's lifting it in the air, isn't it? At the same time as moving it forward. See, he's made it more complicated by doing it this way. So if Gary was right, it was 2.625, wasn't it? Divide that by 2, that would have been Gary's best. So according to Gary, it would have been 1.3. Should have gone 1.3 inches. Okay, so let's measure now the rebound speed of the one mass object. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's 3/8. 1, 2, 3, 4, 5. 3/8. Just over 6/8. Just over 6/8. 13/16. 13/16. So 1 divided by 16 times 13 equals, so 0.8125. That's how far over 5 frames, how fast the rebound object has gone. So is that a third of the initial speed? I can't remember what the initial speed. I said, so the initial ground covered was 2.625, wasn't it? So a third is 2.625 divided by 3 equals, oh wow, that's pretty close, isn't it? Yeah, so this one, it's just lost a little bit, hasn't it? So that's the speed of that going backwards. Yes, I'll put that there. That's what it should have been there. and that's what it was on the bottom. So should have been on the top, what it actually was on the bottom. The incoming was 2.625. That was the incoming speed. Well, that happens regardless, doesn't it? Put that there. So that was the incoming speed. That's 2.625. 2.625 divided by 3 times 2 equals 1.75. That's what that should have been. Yes, that's what that should have been. And that's what it actually was when you take into account my error, 1.75. And it was actually 1.625. So looking at the right, this one I'm shaking now, that's the incoming one. That's the one mass in 5 frames covered 2.65 inches. And the 2 mass should have gone 1.75 inches, but it actually went 1.625 inches. Just slightly under, only a little bit. And Gary would have predicted 1.3. Then the rebound speed of the one mass object should have been 0.875, but it was actually 0.8125. So not a million miles away, roughly a third, roughly 2/3, and that's 3/3. Okay, 3/3, 2/3, 1/3. So there you go. That looked more like a Newton's Cradle type thing, didn't it? Because it was elastic. You see, yeah, I'm filming a video that's already been shot here, so I might as well stop now. I think I've done the work I needed to do just to kind of verify that Gary's experiment does come up with the same results as Walter Lewin's when you actually put springs on. If you don't put springs on, well, so we found something, haven't we? We've found out something useful, because the entire reason, the first reason I built the air track was because I wanted to find out whether or not Gary was right. And I had no idea whether he's right or not. I thought he might be right, actually, on this. When he said that by right, because Newton's cradles work without springs, that was before I appreciated that the ball really is a spring, in effect. Metal on metal collisions should be elastic already, so why are we adding springs? Why is Walter Lewin adding springs to the experiment? And I had some sympathy with that view, and I wanted to test it out, and the only way I was ever going to find out was if I built an air track. Now, of course, I'm making a rod for my own back by doing that, aren't I? Because Gary's going to beat me around the back of the head with it as if it was a steel bar. Because even though I was doing it initially to try and prove him right, really, because I thought he was right, he thinks that springs are cheating. That's it. That's the way he looks at it. So I have to think these things through myself. I get confused. Look, he thought that because Newton's cradle doesn't require springs, forgetting that really those balls are springs. It isn't the same as when we hit these rods, bang them into each other without any cushioning. If the ends were rounded, like, no, if we actually put balls on the end, a steel ball, I think quite likely they would still bounce. I'm not sure, but that's my instinct for how this is so far going. Yeah, so Gary thought that the springs were a form of cheating, that the springs were somehow adding energy, free energy, and I obviously thought that was bollocks. But at the same time, going back a few months before I built the air track, I was thinking, maybe he's right. I was kind of expecting to see, and I wanted to show for once just something of Gary's to be right. I found out that I was wrong when I thought, never mind what Gary thought, I thought that the experiment would still work with just steel on steel, aluminium on aluminium. I thought that should be effectively an elastic collision, and I thought the only reason they weren't doing that was to save damaging the equipment, really. But it turns out I'm wrong. The experiments don't work without some springiness in them. Newton's cradle will not work if you do it with rods hitting each other end on. It will not work because those are not properly elastic collisions. They are perhaps semi-elastic, shall we say. But the clue that these are not elastic collisions is the very fact that the lighter mass object does not bounce off. Even if it was the same mass object, it should still bounce off. I mean, when Gary does it without springs,